Hey everybody, Miss Teacher here. We're looking at number 2. It says select the 3 quadrilaterals with an area of 35 square units. So guess what that means? That means we have to go through each one, identify what type of quadrilateral it is, use the appropriate formula, use strategies that we've talked about in class to see which one might have an area of 35 square units. So let's look at A first. Now we have to calculate the distance between these two dots and these two dots, and we can just do simple counting. So let's do that. 1, 2, 3, 4, 5. And going this way, it's going to be 1, 2, 3, 4, 5, 6, 7. And it's a rectangle, so we would do base times height. And if this line is 7, that means that this line is 7. And if this line is 5, that means this line is 5. So 7 times 5 should do the trick. And of course, we do get 35. So it looks like we're going to be picking that one. That's 35 square units. Let's look at choice B. Choice B. They give us a trapezoid, right? Are you seeing that it's a trapezoid? Maybe we should make it a little bit bigger so you can see it. The formula for area of a trapezoid is area equals half of the sum of the parallel sides, which we call base 1 plus base 2, times the height. So let's substitute in our values and count the dimensions for the parallel sides. So first of all, you need to recognize what lines are parallel to each other. So that's this line and this line are parallel to each other because that's what we're going to use for our bases. So let's count that up. Here we have 1, 2, 3, 4. And down here we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so the parallel lines are 4 and 8. Now the height, recall, has to be perpendicular to the bases. So we have to choose a spot to start counting. How about we start counting right here? 1, 2, 3, 4, 5, 6, 7 would be the height. And remember that number, we can slide that anywhere we want. Sometimes you even see it on the outside, but 7 is the height. Let's substitute that in. All right, and now if we proceed to find the area, we have to first add the parallel sides. This plus this would be 12. And since we can take half of an even number, we're going to go ahead and do that. So this would be 6. So the only thing left you have to do is finish by multiplying 6 times this remaining 7. And ask yourself, does that equal 35 square units? And if it does, you're going to pick that one. If it doesn't, then you're not going to pick that one. So again, this was choice B. All right, let's look at choice C. Let's make it a little bit bigger. We're looking at a triangle. The formula for area of a triangle is area equals half of the base times the height. All right, now for the base, we would look for that one line that matches up perfectly with the grid line. So that would be this line right here. Let's count and see how long it is. 1, 2, 3, 4, 5, 6, 7. And remember, the height has to be perpendicular to the base. So that means if it's perpendicular, it's forming a right angle. And this is going to be a little more difficult than you think. In fact, I think I even want to get my line tool out for this just to make sure I don't make a mistake. So let's use the line tool. We'll make it red. And let's go all the way up from here. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And see how that red line is perpendicular? So that's 10 units times 10. All right, so the next thing we would do, since we have an even number and we can take half of that in our head, we should do that. Half of 10 would be 5. So the only thing left you have to do is to ask yourself, does 5 times 7 equal 35? Because if it does, isn't that the number they were talking about that we're looking for? All right, let's look at choice D. And maybe I can make this a little bit bigger, but we are looking at a square. Looks like a square to me. So the formula for a square, recall, is side to the second power, or side squared. So let's figure out how long one of these lines is. 1, 2, 3, 4, 5, 6. Now, it is a good idea just because sometimes you get what I call an optical illusion and it looks like a square, but it's really a rectangle. So you would want to check going the other way in the vertical direction if that's also 6. 1, 2, 3, 4, 5, 6, and it is. So we can go ahead and do 6 to the second power, 6 squared, which remembers the same thing as 6 times 6. So is 6 times 6 that magic number we were looking for? If it is, you're going to pick it, and if not, don't pick that. All right, let's look at choice E. Now this one, notice that the lines don't fall on the grid. So we have a couple options for how we can do this. The easiest option is to break it up into 2 separate triangles. So let's make this a little bit bigger. So this is choice E. Let me blow this up so we can see it a little bit better. All right, and I'm going to suggest that we break it up right here into 2 separate triangles because we would have enough information to find the area of this top triangle, and we would have enough information to find the area of the bottom triangle. So let's start with the top triangle. The top triangle, we'll highlight it in green. So that's going to be this one right here. And we'll use the formula area equals base times height. And then we have to find the area of this bottom triangle. So let me write the formula for that down over here. All right, so let's focus on the green triangle first, shall we? All right, so we're going to need, this is the only line that matches up with the grid lines. So we're going to have to count how many units long that is. So let's figure that out. 1, 2, 3, 4, 5, 6, 7. The base on that is 7. Area equals half times 7 times the height. All right, so I want to remind you all that the height has to be perpendicular to the base. Remember, that means it forms a 90-degree angle. So we have to go all the way up to the opposite vertex from the base. So that means that we're going to start here. 1, 2, 3, 4, 5 on the base. Or I'm sorry, on the height. All right, now you can kind of see, at least I think you can see, that if we did 7 times 5, that would equal 35. And if we took half of 35, that would give us the area of the green. So you'll be finishing that up to get this value. And let's move on to the blue one, which is down here on the bottom. All right, so we already counted, if we use this as the base, just because that's the only line that lines up perfectly with the grid lines, and we already counted that for the green triangle, and it's the same line, so we know that that's going to be 7. Let's substitute it in. But how tall is it? You have to figure out how many units it is from there all the way to the opposite vertex. So if we count 1, 2, 3, 4, 5. So that pretty much is a mirror image of the one on top of it, right? Or the green one? Same mirror image. So let's substitute that number in. The height is 5, and it's the same computation here. So if we did 7 times 5, we'd get 35. And if we take half of that, we're going to get a number. Now, you're going to go ahead and figure out what half of 35 is, and that's going to be the same thing you're going to get over here. And compare the two numbers because they should be the same. And to get the area of the entire thing, wouldn't you be adding those two separate areas together? So if you add this plus this, do you get 35? Because that's how you would find the area of this entire thing. So if you do, then that's one you're going to pick. All right, and I think that's it, right? Those are the choices. So decide which ones equal it. Let's go back and look at the question one more time. So the question was, select 3 quadrilaterals that have an area of 35 square units. We looked at all these choices. So go ahead and pick the ones. Remember, you got to pick 3. All right, good luck finishing this up.